All right, guys. Well, welcome back to Rex and Rides, where we are going to help you turn your hard-earned money into broken hopes and unfinished projects. Hopefully not. So, if you enjoy this, you like the video, please like and subscribe because we need the money. And speaking about the money, we've been procrastinating this bit of rust that we've got here because budgetary. You don't want to replace all your rust, not get everything sanded and primed straight away, because then it's just going to rust again, isn't it? However, we got into a bit of a pickle here because I want to get the tailgate off. The tailgate's got a plate right on the inside which I can't get out, and we need to cut this out to repair the rust. So I thought, well, let's cut it out. Then we can get that out, can get the tailgate off, get everything cleaned up, and then we can patch this. So, well, now we're sitting. Body work on these things is amazing. It's very thick. It's almost a millimeter thick. So it's not going to be very hard to weld the section on. Our first step is obviously to determine where all the rust damage is. So we know about this corner here. We know that this is really the only major rust bit. What we didn't know about is this over here. That is also been a bit of rust. This is nice because this section is flat, so we can just cut a piece of sheet metal and weld it in there. This has got a bit of a contour to it. So fortunately for us, I've got a Mercedes-Benz W124 fender that has a bit of a contour to it here. So what my plan is to cut the section out, perhaps over here, and I'm going to do this in two sections. I'm going to weld in there, and then I'm going to do in there. So I think first we're going to clear out and see exactly how far the rust is, and then we're going to cut a section out of here. And before I cut this, what I want to do is get the section on there and then just mallet it a bit so we make sure the contour is the same. So let's get to it and see what we can make out of this. And like I say, it is really the only bit where the rust is not just surface rust on this vehicle. The rest of the stuff is just surface rust, really. It's really in good condition. So yeah, this is going to be our focus. It's a nice little project. I've not done it before, so just like most of the things, I've not done it before. How hard can it be? Let's go for it. Right, so as you can see, man, this is a good selection of cut to use, because it's really it follows a contour perfectly. If it's not following the contour perfectly, you see, you don't want to cut it out yet. You just want to hold it there and get a mallet and cap it to follow the contour, but it follows. And then what I've done, I first cut my piece, hold it there, and then I've just scored it with a grinder to mark the shape of this. Then what I'm going to do now is cut it well on the inside of that line. So when it comes to welding this in, I can get a flush fit. Because as snug as you can get that connection there, it's just going to make your life a lot easier when it comes to welding it up. If you can get a really, really tight fit, you can even tack it in with a TIG. But I think on material this size, I'll probably end up sticking with a MIG welder. We're pretty healthy all around the corners, maybe not so much at the bottom, but the corner is good here. So that will make fastening this bit on a lot easier. All right, off to cut it. yeah, we're going to get up close and personal with this because, man, see, there's a little rust ridge there, but it's very little rust. I mean, this is all surface, yeah, and this is actually just dirt that's gotten itself in there. A good clean material around the side to get something on. So I'm going to leave it there. So I've got a bit of a brace before we get this in. It's very difficult with one hand, but look at that. It's a snug fit all around the edges. And what we're actually going to do when it comes to welding is put a magnet there over here, tack it. A magnet at the bottom, tack it. And so we slowly get this sheet metal into its correct form, very slowly, not too much heat. And I'm still deciding on whether or not we're going to use the TIG on pulse or if we're just going to use the MIG, but we'll see when we get to that. So that will be continued at a later date, and we'll get this bit of rust off and cut a piece very similar, and then we'll return to the video. But for now, I'm going to get this tailgate off because I can now access that little bracket over there, and hopefully it will come off. See you guys in a bit. Alright guys, so welcome back to Rex to Rides, where we are still turning your hard-earned cash into broken dreams and unfinished projects. Gonna look down here for a little bit. So, just on projects, you may look at things and going, yeah, but he's using a rattle can with primer on this, and what is he doing in that? Uh, this is going to be a long-term project. So, what we want to do, essentially, I have to get the tailgate off, you can recall. So, to get the mechanism out, I couldn't get it out from the inside, so I had to do this rust repair. So here we are sitting here. I managed to mock up a nice piece of sheet metal from the Mercedes 280E's old fender. And what happened then was I found that I've completely lost where I am. Yeah. So anyway, so I've got a cut, and I've got a really, really, really nice fit. And then I was asked, what welder do you ever welder that can weld thin sheet metal? Well, this ancient thin sheet metal, that's for sure. Um, so I sort of found myself in a situation where we had to do the repair now, and that's why I've got a rattle can to just go over this because we don't want any rust from once I'm done until I get to the whole the entire bodywork, get primer on and everything. So that's why we're using that. Um, because just again on unfinished projects, a lot of projects don't get finished because the guys are looking at this thing like, it's overwhelming. I've got to do I've got this rust to cut out. I've got to get sheet metal. I've got to get it in. I've got to get the primer on. I've got to get the filler on. I've got to do this. No. A project is just a series of tasks. And what you got to do if you want to finish a project is finish the task. This requires a lot of discipline to get these tasks finished. But yeah, get it finished. So our aim here is to get this rust removal in and well, cut out, filled in. I've got this and I've got this. I'm leaving that corner until I clean it up. It's ready. Like I said, this is still so hard. Yes, I mean, if you could see, I had to use a impact SDS impact drill breaker to actually bend this out as best I could. So yeah, what we're going to do is get this in, get this welded up, and get it sprayed, cleaned up, sprayed, ready to go. So there's two different types of machines you can use. You can actually use a normal stick welder on this if you're good. It's that thick, but I wouldn't recommend it. You're going to get burn throughs. You don't want burn throughs. And then you got a difference between you've got a MIG or you've got a TIG. I've got both. Um,
I'm more experienced on the MIG. The TIG is more versatile. Before we get into the actual welding of this, we have to understand what happens when you weld. First off, you've got penetration. You have to look at your penetration. You want maximum penetration here. I'll tell you why. I want to grind this quite smooth because I've got a really, really tight fit here and a great profile. The profile's matching, everything's great. So I want to get this as flush as possible to use as little body filler as possible. So I want to make sure I've got maximum penetration into the sheet metal without any burn throughs. And if I do get a burn through, I can patch them up and but I don't want a lot of heat going in here. So the thing with welding is that heat is not a result of amps. Penetration is a result of amps. Heat is a result of spending a lot of time in one place. And what happens when you do body work like this? Apparently, because I've never done this before, so this is my first time for everything, which is why I'm really aiming at this channel. At the guy at home who's doing a restoration, he wants to get the project finished. Not looking at high-end professionals. If you're a high-end professional, that's really admirable. But these are just for the beginners. So yeah, that's what we've got. We've got penetration. We want to spend as little time as possible at any point because heat is going to cause distortion and it's going to destroy. Look, you're going to get a bit of distortion, but too much heat. It's just going to buckle this whole lovely fit I've got here. So we got those two elements. On those elements, you can either get yourself a TIG welders, or you can get yourself a MIG welder. Now your TIG welder, we're going to spend a bit of time on these. TIG stands for tungsten inert gas. So what you've got is a tungsten bit. It's a steel bit. It's fixed. You can see this point isn't great. And when you pull the trigger, I've just got the torch here, it's going to create an arc between here and the sheet metal. And coming through the pipe is your electricity for the electrode that comes out the tungsten and gas, your cooling gas. Now, TIG has to use argon gas. The reason for that is the argon gas cools. So it's going to cool down your tungsten so your tungsten doesn't burn up. And that's an important thing to remember for a little later on. So when you get on here, you want to get your tungsten tipped as close as possible and hit it, and you're going to get what's called a fusion weld. It's going to melt the existing material together. Now, with that, you really have to have a perfect fit. I've got about half a mil gap in here. It's all held up by magnets. And from what I found with the TIG, when you put a blast of energy in, is that it can choose a side, which is the weaker side, and burn away if you don't have that snug fit. The two pieces have to be butted up together. So you can lose control of the TIG. The other thing is that you fill it in with a filler rod. So as you're going, you're filling it in. This is just creating a heat spot, and the filler rod's filling the metal. If you don't have filler in there, you don't have a stronger weld, and that fusion weld can crack. So you've got that option. The pros of using a TIG is that if you've got a snug fit, you can tack it, tuck, 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 and it's done. The other pro is that you can put it in pulse mode. So what it does is it puts a blast of heat in, or of current in, and then backs off. Blast, backs off. Blast, backs off. So it's just causing a weld and then letting it cool. Causing a weld, letting it cool. And this prevents a lot of heat. So I mean, like on stainless steel, where heat is your enemy, um, you've got a pulse mode that does that, and that's fantastic for this. I have tried before. I've sort of done all right, but I don't. Basically, I don't feel confident enough on the TIG to attempt this repair. Being my first repair, I don't want to be struggling with welding. So if you're looking at a welder, a TIG is great, especially an AC/DC one. Then you're welding stainless steel, you're welding cast iron, you're welding aluminium. It's very versatile, and it's an amazing art form. It's a lot of fun. But for this, I just don't have the confidence. to use the TIG. So we're not going to use the TIG on this, we're going to use our trusty old MIG. Now with the MIG welder, slightly different because it's got a bit of wire, filler wire coming through the middle, and then gas comes around the side and it acts as the electrode. So the current is coming down the wire and it's causing the weld here, but it's also filling in. So you will never get a fusion weld on a MIG. You're always putting filler wire in, so you might get a bit of a heap over the top, depending on what your current's set at. And the advantage is that your TIG can run on either argon or it can run on a CO2 or CO2 mixtures. I'm using Terrell. So it's a bit hotter. Remember not to confuse it with heat. It's on the weld, it's hotter. So you're going to get more penetration using CO2 than you are going to get with argon on this particular application. That's the way I see it. I've given this a lot of thought. I could be wrong. Like I say, bottom line here is I'm a lot more confident using the MIG on this application than I am using the TIG. So my gas is coming through. I'm set to 50 amps and we're good to go. What I'm going to do is just nip a bit off. Then as you can see, the wire feeds out, so it's feeding in through the weld. And I'm a lot less likely to get a burnt. So I've got these magnets in place. I normally use a glove on my left hand, and then I don't have a glove on my right hand, so I can control the torch with a glove. I use a full arm, so I can also shield it. We're outside, shielding gas. Shielding gas is just to prevent oxidation. And on the TIG, like I said, to cool down your little tungsten tip. But I want to really, really feel what's going on here. So it's going to be a bit hours. I'm going to burn myself here and there, but nothing can heal. And I really want this fit, because if that's sitting a bit higher and they're not in line, when you start sanding, you're just causing a soft spot and a very thin spot. We don't want that. It's relatively thick metal, so I'm not really anticipating a lot of problems, but yeah, let's hood up and go for it, eh? Wish me luck. Okay guys, check that out. This is not bad for the first attempt. Just a little bit about body filler. Body filler is quite hygroscopic, so it can absorb water. So that's why I'm getting some primer down. When you're ready for all the body filler, we're going to get proper 2K primer on here. But for now, this is just going to prevent rust on our new weld. But look at that, man. That is really quite straight. You're always going to get a bit of distortion. There's no getting away from it. One thing to remember, you'll see me changing discs quite a lot. You really want quite a bit of a rougher disc or a grinding stone initially, because a smooth sanding disc, you might think that's going to give you the best finish, but it isn't really, because let me see if we can't get some light on that. No, don't have a light. It's just putting more heat in because it's taking more time. But yeah, so we pretty much protected against rust, so we can leave this for a bit. Our next step is to cut out this bit and do exactly the same. So yeah, if you enjoyed the video, there you could see it's quite nice because it does go in a little bit. There's nothing really protruding out, so that should fill quite nicely. And yeah, you're not going to notice it. It's a nice new piece of steel, and winner chicken dinner. Job is done. So yeah, if you enjoyed this video, please like, subscribe, and yeah, follow us for more on our little Isuzu. Thanks, guys.